What's up, everybody? I wanted to share an update on my 3D printed triaxial clock that I posted about a few weeks ago. I've actually been working with the original designer, mcmaven, to make some updates to it. The first one that I've done, I got some comments about how the timekeeping was off, and it absolutely was, just with the nature of the tolerances of 3D printing and how it was all put together. The hands would never really be right. The other thing is you would have to constantly be running it for it to keep accurate time. And even then, like I said, it wouldn't be that accurate. So what I've gone ahead and done is I've replaced some of the gears behind the face here with an off-the-shelf quartz clock movement. And I'll share a link in the description to that, but basically it completely isolates the timekeeping aspect from the whole movement mechanism. So whether it's running or not running, the time will always be right up to within the accuracy of the quartz mechanism, which is pretty good from what I've seen. The other major update is instead of being driven by a weight, this is now motorized. So taking some of the enhancements from the gyro model that mcmaven designed that's powered by a stepper motor, this one is also powered now by a stepper motor. So I've got it connected to a 5-volt battery pack that's connected to an Arduino with a stepper motor on it. I'll show you those electronics here in a second. But if you go ahead and push this little button back here, should start ticking away. And there it goes. So this should go around and around and around until you turn it off or the battery dies or something gets hung up. But so far my testing goes around, I've probably only left it running for 20 minutes at a time, but it hasn't stalled out on me yet. So I'm going to go ahead, I'll pop the back off of it, show you some of the wiring, and then I'll show you a time lapse of it kind of all working. Alright, so I got the back off the clock now, and you can see what's on the inside. We've got an Arduino Uno, it will be powered by 5 volts. Got a stepper motor driver board, the 5-volt stepper motor, and then down here we've got a rotary encoder with a push button on it. So that turns it on, turns it off, and it also allows you to speed up or slow down the stepper motor. It's not really to make the thing go faster, but more to tune it in to your the movement of the tourbillon so that it will run correctly. If you get it running too fast, this thing will bind up. If you get it running too slow, it'll bind up. So you can use that rotary encoder to find the right speed to where it runs reliably through the whole motion. And then up here is just where I've hot glued in that blue LED to indicate whether or not power is turned on or off. So you've got 5 volts going to the stepper motor, which is connected in through here, that's sending it all the signals, and then your 4 signal wires to the stepper motor. Single pin here is the LED, and then these 3 pins are the 2 pins for the left and right motion on the rotary encoder, and that last pin there is for the switch mechanism. The switch function on the rotary encoder, the push button. And then, so, like I said, 5 volts and ground going to the stepper motor, 5 volts and ground going to the rotary encoder, and then you've got your ground wire here for that LED. So that's pretty much it. I'd like to thank mcmaven for his awesome design and continued enhancements. I'm gonna probably leave this as is for now and move on to printing his triple axis model. The final thing that I'll show you here is in the back of this, you can see this box with the AA battery in it is the quartz movement for the hands for the accurate timekeeping. So I hope you like this update. Let me know if you have any questions.